In order to prove Ohm's law, we can use the simulation. We start connecting a battery to wires. We branch the ammeter in series, and we connect a light bulb to the circuit. Next, we need to fix our voltage to the starting point, which is 5 volts, and we start recording the reading of the current. So we're increasing the voltage and we're recording the current in amps. Next, we want to see what happens to the current as we increase the voltage, and as you can see, you can notice that it's increasing as well. Now, to plot the graph, we start by plotting the dots, and then you draw the line of best fit. To analyze the graph, we need to pay attention over two important things. Number one, the graph is linear as it goes through 0. 2, it's a proportional relationship. That's because as the voltage increases, the current is also increasing. We calculate the gradient by finding the rise divided by the run, choosing 2 points from the graph, the line graph. Alright, now we know that the gradient is equal to 2, but it's equal to what? You can see that your rise is in volts while your run is in amps, so it's as if we're dividing volts by amps. This quantity is called ohms. So this is the resistance. Now we will see how increasing the wire resistance will affect the flow of electrons, the brightness of the bulb, and the reading on the ammeter. Alright, so we start increasing the wire resistivity. We can see how the electrons get slower, the bulb gets dimmer, and the current, the reading on the ammeter gets smaller and smaller. What if we increase the wire length? So start dragging your circuit, increasing the wire length, extend it as much as you can. And you can see how the current reading is getting smaller and smaller. So the flow of electron will also get slower, bulb gets dim, and the current reading gets smaller, so it decreases. A lot of students will ask, why wouldn't we plot the current on the y-axis and the voltage on the x-axis? Well, we can plot the current on the y-axis and the voltage on the x-axis, respecting the variables, but you can see that when you want to find the rise divided by the run, the gradient of the slope, you will no longer find a quantity that is in volts per amps instead. So it's not ohms. Instead, what you're finding is your rise is in amps and your run is in volts. So how can we find then the resistance? It's by simply finding 1 over the gradient. So we do 1 over the slope that we find, and that's the reading of the resistance.